Hi guys, my name is Vaishnavi. In this video, I'll be talking about general structure of the inner ear and structure and function of its vestibular part. The internal ear is located within the temporal bone. The bony labyrinth houses a set of continuous fluid-filled epithelium-lined tubes that make up the smaller membranous labyrinth. Two divisions of the membranous labyrinth are the vestibular and the cochlear labyrinth. Vestibular labyrinth mediates the sense of equilibrium and consists of two connected sacs, the utricle and the saccule, and three semicircular ducts arising from the utricle. In each of these structures, the epithelial lining contain large areas of columnar sensory mechanoreceptors called hair cells in specialized region. First one being maculae of utricle and saccule. Next, in the crista ampullaris, in the ampullary regions of each semicircular duct. And the last one is in the organ of Corti, in the cochlear duct. The bony labyrinth has a central cavity, the vestibule, where the saccule and the utricle are located. Three osseous semicircular canals enclose the semicircular duct, and on the other side of the vestibule, the cochlea contains the cochlear duct. All regions of the bony labyrinth are filled with perilymph. Perilymph emerges from the microvasculature of the periosteum and is drained by the perilymphatic duct into the adjoining subarachnoid space. The fluid suspends and supports the closed membranous labyrinth, protecting it from the hard wall of the bony labyrinth. The membranous labyrinth is filled with endolymph, generated largely by the capillaries of the stria vascularis in the wall of the cochlear duct, and drained from the vestibule into the venous sinuses of dura mater by endolymphatic duct. The saccule and the utricle are composed of thin connective tissue sheath lined with simple squamous epithelium. The maculae of the in the walls of the saccule and utricle are small areas of columnar neuroepithelial hair cells that are innervated by branches of the vestibular nerve. Both maculae contain mechanoreceptor cells called hair cells, which use gravity and endolymph movement to detect the orientation of the stationary head and linear acceleration of the moving head. The maculae is composed of hair cells, supporting cells, and ending of the vestibular nerve of eighth cranial nerve. The apical surface of the hair cells is covered by a gelatinous otolithic layer or membrane, and the basal ends of the cells have synaptic connections with the nerve fibers. The apical end of each hair cell has a single kinocilium and a bundle of uh, unbranched stereocilia. As said, the tips of the stereocilia and kinocilium are embedded in a thick gelatinous layer of proteoglycans called the otolithic membrane, the outer part of which is filled with calcified structures called otoliths. There are two types of hair cells. Type 1 have basal lengths and are rounded, and the type 2 cells are columnar. These semicircular ducts are part of the membranous labyrinth. Each extends from and return to the wall of the utricle. The enlarged ampulla of each semicircular duct has an elongated ridge-like area of mechanoreceptors called the crista ampullaris, which is similar to macula with hair cells, supporting cells, and nerve endings. However, the proteoglycan layer called the cupula attached to the sensory cells, hair bundles, is thicker and doesn't contain otoliths. The cupula extends completely across the ampulla, contacting the opposite non-sensory wall and is moved by endolymph movement within the semicircular duct. Sensory information from the vestibular labyrinth is used primarily in the reflex mechanism for maintaining upright posture and balance and in allowing the eyes to stay fixed on the same point despite changes in the head position. Movements of the head cause movements of the endolymph, which move the otolith membrane of each macula and the cupula over each crista ampullaris. The sensory hair bundles bend with the movement, changing their resting potential and their rate of neurotransmitter release to the afferent nerves. Neurons of the vestibular nuclei in the CNS receive inputs from the sets of semicircular ducts on each side simultaneously and interpret head rotations on the basis of the relative transmitter discharge rates of the two sides. Together with inputs from mechanoreceptors of the musculoskeletal system, the information interpreted to provide the basis for perceiving movements and orientation in space for maintaining equilibrium and balance. Thank you.